Hi, my name is Luntha and I am the project engineer at FoodSmart and at Cubics Robotics. So today I want to take you through our Lilongwe office so that we can see the things that we do at FoodSmart and at Cubics Robotics, but also show you some of the works and our innovative projects that we have in store for you. So please, I implore you to stay with me and let's go through this together. So, Cubics Robotics is essentially a digital manufacturing company, and so the work that we do revolves around taking small ideas and then producing them at a mass scale, which is impractical when you talk about high scale or large scale manufacturing. So we're essentially looking at producing something from an idea stage and attaching all the components that are related to industrial manufacturing, but then producing it at a small feasible scale that new entrepreneurs, new ventures, and new people that are into the digital manufacturing space can actually get their ideas produced. So we have a lot of equipment, we have a lot of machinery, we have a lot of things that we use for our digital manufacturing platform, but at the heart of it, we're looking at technologies such as additive manufacturing and subtractive manufacturing. So when I talk about additive manufacturing, what I'm talking about is producing an object or producing a product by adding layer by layer of material onto whatever substrate to produce an item, and this is a 3D item. Now let me unpack that a little bit more. When we're talking about a 3D item or a 3D object, this is something that we're designing using computers. So we're using computer-aided design software, or simply known as CAD. We're using CAD to model the product that we want, and then from there we take it through some processing, whereby we now come up with a file that can then be printed by a machine. And we use a 3D printer which uses plastic to create this 3D representation of your product in actual space or in the real world. So we take your idea from just an idea, we create this 3D representation of your idea, and then we manufacture it using 3D printing. But we also do subtractive manufacturing, which involves taking material from a starting material or a base material. So here we're looking at, for example, if you have a big block of wood, for example, we have things like furniture, whereby you need engravings or some complex patterns that may not be possible if you're using hand tools. In this case, subtractive manufacturing is the way to go, whereby we carve out surfaces of materials to come up with finished products. So unlike the additive manufacturing or the 3D printing, whereby we're starting off with nothing and then building layer by layer until we get the product that we want, with subtractive manufacturing what we're doing is we're removing layer by layer of material until we're left with the thing that we want. So here where we are is the heart of the R&D, or the research and development, where we develop systems or we develop hardware products for either Cubics, or if you're a client and you need any hardware done, this is where it happens. So with me here as the project engineer, my work is focused on coming up with hardware designs, and we're talking about electronics, theorizing how the product should be, creating the circuits, and then soldering these circuits, piecing together various hardware components, and then coming out with the final product, or maybe a prototype that can then be mass produced by bigger manufacturing factories. So we have, for example, China, which can mass produce circuit boards, of which we don't have the capacity yet, but once we design those products, we can then have them manufactured at a larger scale. So you're looking at coming from an idea and then creating something that can then be mass produced or mass replicated. So with me, most of my work revolves around crafting circuits or crafting ideas. And as a project engineer, the fun of my work is somebody coming to me with an idea. Okay, so I need a device that can, for example, control your home. So we're talking about smart homes in this case, a smart home. So I need a device that's gonna be able to tell when I'm back home, maybe turn on the lights, or maybe turn on infrastructure, appliances, turn them off if I leave, or turn them on if I come, and probably any other idea. It can be any idea, and you come to me, and so from there I start now theorizing how can we execute this, how can we implement this particular device or circuit or whatever it may be, system. So my work revolves around creating these devices whereby I now start to piece together different hardware components, sensors. You have boards, or what we call microcontroller boards. We have single board computing devices called Raspberry Pis. There's a lot of things, a lot of components that are involved in this digital manufacturing space that we can then utilize. I then piece together these sensors, and then I write some code to piece this together, join them together, and then at the end of the day I come up with a design that can then be manufactured or produced by bigger manufacturing entities, for example these circuit board producing companies. But when we talk about Cubics Robotics and our role in digital manufacturing, what we're targeting mostly is small entrepreneurs, or maybe even big entrepreneurs, whereby they have an idea that they need to have manufactured, and they come to us, we take them through the idea, we theorize how we can produce it, and then we start implementing this idea by producing various components. So here we can produce the actual hardware, the actual circuits. We can also produce the outer casings, for example, the packaging of your device. If you're talking about packaging, I'm talking about, for example, the smartphone itself has these various components connected together, but the heart of it, or rather the glue of it, is the frame of the phone, right? So the frame itself is what is piecing together all these components to make your smartphone as you know it. So what we can do for you is create you that frame, but also piece together all these components so that you have an entire product as the end result. So you can have different services. For example, you can just say I need just a cover, or I just need a piece of my device manufactured. We can do that. There are some devices, some pieces of equipment that are complex, and if it's broken down, repairing it is not really feasible because these are complex and sophisticated shapes and patterns. With 3D printing and digital manufacturing, what we can also do is just scan the particular component that needs to be replicated, and then in the 3D environment reproduce it into a 3D file that can then be printed by our 3D printers. So you're looking at such kind of applications, such kind of services. You need custom engravings, you need custom shapes, whatever it is. Cubics Robotics is at the heart of manufacturing those things for you. So one of the things that is relevant when we talk about 3D manufacturing, or maybe digital manufacturing, is that most people do not actually know how do we take something from just being an idea, creating it, piecing it together, and then coming up with a system, with a product. and it is what we're doing here. So this is where the magic happens, whereby we have various components, various devices that we use to come up with these ideas. There are some things that we need sophisticated equipment for, and with just regular equipment, it cannot be possible. That is what we have here. So that is what we focus on. We focus on getting the things that other people, normal people, can actually not afford to, or maybe they do not know about. That's what we're bringing in, and that's what we have for the process of digital manufacturing. So we're taking ideas, creating them into a 3D environment. We're then theorizing how we can piece this together, how we can mass produce it, and then we start off with now our equipment and our machinery, whereby we now produce it. So here is where the R&D is mostly done, and we're focusing on creating IoT systems and other products that are revolving around electronics and hardware. And so that's what our main focus is at the Lilongwe office. We have bigger and more powerful digital manufacturing equipment, 3D printers and CNC machines, bigger, more powerful ones, but those are in the Luntha office. But here our emphasis is to develop these IoT ideas. We have monitoring, remote monitoring, we have elements of electronic products that we emphasize on manufacturing here. So this is the R&D center, or the Research and Development Center. So I talked about additive manufacturing, and essentially the process starts here. What we have here is a 3D file, which we can then configure and prepare.
The Holy Father, Pope Francis, is inviting all of us to journey together in the spirit of synodality. Every Catholic in the world is